Hey guys, I wanted to go over real quick with you guys section 5.2, which can be a little bit complicated for a lot of students. So let's just kind of go over that. If you guys have any questions, please feel free to email me and I can try to help you guys as much as I can. So let's open up. Hopefully everybody can see this. Okay, here we go. So, like I said, for some reason, the old edition that switched from last year to this year, your chapters are all the same, but for some reason, the order of them got out a little bit. Hopefully no one has the old edition, but if you do have the old edition, that's the same as the new edition would be chapter 5, and then the old edition would be chapter 6. So that's why on some of your weekly lessons, I have used some of my videos from last year, and I changed the section date just because it was off just a little bit. So this week, you guys are going to be looking at the notes for 5.2, and then you need to work on your project or finish working on your project. I gave it last week. It's going to be due next week on the 4th, November 4th. And I am going to attach a couple of examples, but please feel free to contact me if you guys have any questions. It's not supposed to be a really difficult project, and it's supposed to be a project that helps you guys boost your grade, average up a little bit. It counts as a test. So please make sure you do it and you do it correctly. All right, so 5.2 is on the normal distribution. If you look in your book, you can kind of follow along. The normal distribution, let's see, is used in statistics and describes more your real life data than any others. It's one of your more commonly used distributions. And excuse me. The reason for that, it's a bell-shaped curve, and your mean, your median, and your mode fall in the middle. And so that means 50% of your data fall on one side of the mean and 50% of your data fall on the other side of the mean. This is your bell-shaped curve. And we usually look at the mean for your middle ground here. We've already talked about how to find mean in the last chapter, also how to find median and mode, and how to find standard deviation. So that's why I do chapter 4 and 5 together, because a lot of this stuff builds on each other. Your inflection points are a point on your curve where your curve changes from being curved up or curved down. So here our inflection points are your standard deviations, how far apart you are from the mean. And so mu here is the same thing as your mean. So sometimes you'll see mean written as a mu, and sometimes you'll see it with the X bar. So this means the same thing as mean, and you'll also see it like written like this, okay? And then that little symbol here, this is your standard deviation symbol. Okay, so from your mean, if you go one standard deviation this way or one standard deviation this way, you're going to be 68%. We usually just say 68% here. We don't usually say that 0.26. If you're 2 standard deviations from the mean, okay, then that means you're 95%. And then if we go 3 standard deviations, we usually say 99.7%. So let me kind of tell you what I'm talking about here when I say that. Let's see here. Let me get up. Let's see if I can get a blank page here for you guys. No. All right, I'm gonna get the whiteboard. All right, let's say I give you a mean of 7, and I tell you your standard deviation is 5. Okay, and I drew my bell-shaped curve. And I asked you guys to find the first, where 68% falls, okay, what your data falls between this, okay? So what you would need to do is you would need to find the standard deviation from the mean from 7, 5 this way and 5 that way. So if I'm going to go 5 this way, that would be 7 plus 5, right? And 7 plus 5 we know is, goodness, what am I doing down here? 12, okay? And then we go 5 this way, which means 7 minus 5, and that's going to give you 2. So what that means is 68% of your data is going to fall between 2 and 12, okay? 68%. Now, I should have come up with another number here because we're not going to have negative numbers, but let's just do another one. Let's say your mean is 15, and let's say our standard deviation is 2, okay? So 15 goes here. We're going to go 2 this way, which will be 17, and 2 this way, which will be 13, okay? So that means 68% of your data is going to fall between 13 and 17. All right, then we go 2 more this way, which would be 19, and 2 more this way, which would be 11. So 2 standard deviations means 95% of your data will fall between 11 and 19. And then 2 this way would be 9, and 2 this way would be 21. And that means that 99.7% of your data will fall between 9 and 21. Okay? I just kind of wanted to go back over how you would use that. But let's look at an actual example. All right. Goodness. All right, so a few before we do the example, let's go over the properties of a normal distribution. As we just went over, a normal curve is bell-shaped. Your highest point on the curve is at the mean of the distribution. So here's our normal shaped curve, right? The highest point, this is your mean. The mean, median, and mode of the distribution are all going to be the same for a normal distribution. The curve is symmetric, so that means that on this side is the same as this side. That's where that 50% comes from. Okay, and then the total area under the curve is 1. And if we're thinking about that as a percentage, that means 100%. Okay, roughly 68% of the data is within 1 standard deviation from the mean, and then roughly 95% of the data is within 2 standard deviations of the mean, and then roughly 99.7% of the data is within 3 standard deviations of the mean. All right, suppose that the distribution of scores of 1,000 students who take a standardized test is a normal distribution. So that tells you right there that it's going to be normal. Okay, we have a sample size of 1,000 students. So sample size equals 1,000 students. That's our N. Okay. If the mean is 450, so my X bar is 450, and my standard deviation is 25, S is 25, okay? Find how many scores do we expect to fall between 425 and 475. So first we need to look at our normal distribution. We know it's normal, and we know my mean is at 450, okay? So let's try to determine first what would 1 standard deviation be. So that means I'm going to have to go 25 this way, which will be 475, and then 25 this way, which will be 425. Okay, so that's 1 standard deviation. And notice here, our 1 standard deviation matches up with what they're asking for. So 1 standard deviation, our data would be 425 and 475. So we want to know how many scores do we expect to fall between that. Well, I know that 68% of my scores fall between this. This is 68%. Okay, so how do I figure out how many scores of those? Well, I know that there's 1,000 students, and I know 68% of those 1,000 students fall between 425 and 475. So how do I figure that out as a number? Well, 1,000 students and 68%. So how do I deal with the percentage? We change this to a decimal. 68%, your decimal's here, move it 2 places to the left. That's 0.68. And we multiply those. And so 1,000 times 0.68 is our 680. So that means 680 scores or students, right, will expect to fall between that one standard deviation. How many scores do we expect to fall above 500? Okay, well, let's go ahead and finish our normal graph, right? Our mean is 450. We know one standard deviation is 475 and 425. Okay, that's one. Let's find the two. 475 plus 25 is going to be 500. And then 425 minus 25 is 400. So two standard deviations would be that. And then we go 25 more would be 525, and 25 this way would be 375. And this is your 3 standard deviations, okay? And we want to know how many are going to fall above this, okay? So what we do know is from here, okay, let me get a different color. I know from 2 standard deviations, right, from here to the 500, that's 2 standard deviations, would be 95%. So I know that 95% of the people are going to fall within 2 standard deviations. Well, I want to know this part. Well, we know what's left over from both of these, right? If 95% is all of this, and then what you have left over, okay, our whole normal distribution here is 100%. So that means that 100% minus 95, that means that these 2 yellow pieces on each end leaves us with 5%, okay? But we don't want both of these. We want just above 500. So if these are the same on each side, then all I would have to do this distribution is to divide it by 2, and that would give us just this part, which would be 2.5%. And we want to know how many again. So again, we would take our 1,000 and we would multiply it by the decimal of this, which would be moving it 2 places to the left, which would be 0.025. And I know that this would give us 25 students, okay? So that means that only 25 out of 1,000 are going to be scoring, expected to fall above the 500 score, which makes sense because this is a very small percentage of students. All right, so z-scores, sometimes we like to predict how many values lie, maybe not exactly 1 standard deviation or 2 standard deviations or 3 standard deviations. So for example, if you want to know the weight of women between the ages of 18 and 25 of a normal distribution, or you're wanting to know the percentage of a female population of a big company between 1.3 and 2.5 standard deviations, we're going to use something called the z-score table, okay? And the z-scores represents the number of standard deviations from the mean. So we use z-scores when your standard deviation isn't your nice, perfect 1 standard deviation, 2 standard deviations, or 3 standard deviations. And if you take a look in your book, there is a z-score table on page 351. Everybody can take a look at that now. And so what you'll see when you take a look at that is a list of your z-scores. On the left-hand side is your z and then your decimal. So let's say your value, you're looking for 1.11, then you would scroll across your table to that 1.1, and then you would go to that 0.01 and you would see 0.3665. And so what that means is 36.65%. That's what 1.11 represents, okay? All right. So you're going to have to be able to find areas under the curve between z-scores. And for these, what I suggest you do always is to draw your curve so that it's a little bit easier to read, okay? So let's look at the first one. We're looking at between 0 and 1.3, okay? And if you look on your z-score sheet, the 0 is always your middle number, okay? And we're going to 1.3, and this is your positives. Okay, so what I'm going to do is I'm going to look on my z-score sheet. I'm looking for 1.3, and that number is 0.4032. So that means that from in here would be 0.4032. And so how much percent would that be? Would be 40.32%. Okay. All right, next we're looking at from 1.5 to 2.1. So this one doesn't, here's 0. We're looking at from 1.5 to 2.1. So we're looking at this part right here. Okay. So the problem is we want the middle part. So remember, we're always going from 0. So we look at from 0 to 1.5. We're looking at from here to here. And then we're looking at 0 to 2.1. And we're looking at from here to here. And what we want is we want the overlapping part. We want just this part right here. Okay. So what you would have to do is you would end up subtracting here. So you would have to find the 1.5, and then you would have to find the 2.1, and you would have to subtract these to get what's the overlapping part. So let's look up our 1.5. If you look up 1.5, you get 0.4332. And then if you look up 2.1, you get 0.4821. Okay, and so what we want to do is we're going to subtract these numbers. So 0.4821 minus 0.4332. And you get 0.0489. And again, we want a percentage. So what we're going to do is move this 2 places to the right, and you get 4.89%. Okay. And then the next one is the negative, okay? And so that means we're going this direction, negative 1.83, okay? And since what we know about a normal distribution is that they're the same on each side of these. So if I can find the positive 1.83, then I know what the negative is, okay? So that means that we need to go to 1.8, and then we're going to go over to the 0.03, and you end up with the value of 0.4664, okay? Which means that the negative is going to be the same thing. So that means that this percentage is 46.64%, okay? All right, so one more I want to do with you guys. Let's say your z-score is, you want to find between negative 1.3 and 1.5, okay? If you have the same direction, the trick is you'll always subtract your two numbers. So same direction, you will subtract the two numbers, or two z-scores. And if you're going in different directions, meaning you have a negative and a positive one, you're going to add those two numbers. Add two numbers. So for example, okay, we're going negative 1.3, which we know the same as positive 1.3, and then 1.5, okay? We want both of these, between both of these, and see how they're going in opposite directions. So what we do is we look up the 1.3, which is 0.4032. Can't read this. 0.4032, just like this one, right? And then we look up 1.5, and that's 0.4332, and then we add those two up, okay? So we add those two up, 0.4032 plus 0.4332, and we get 0.8364, which means this would be 83.64%, okay? All right, you can also convert your to raw z-scores. So let's say we're given a data value, we're given the mean and the standard deviation. We can find the raw score of this. What would the z-score of this be with that information? And to do that, you would use this formula. You would do your data value minus the mean all divided by the standard deviation. So if you had a mean weight of 20 pounds for a dog with a standard deviation of 3, can you find the z-scores of this? Well, this is your data value. So you do 25 minus your 20, which is your mean, all divided by 3. And so that ends up with 5 over 3, which means that your z-score is going to be approximately 1.67. Same thing for this one, 16 minus 20 over 3, that's negative 4 over 3. Which is negative 1.33, which we know this is the same thing as your z-score of 1.33. All right, so let's say we are interpreting the significance of exam score. So what if you want a score? Goodness, what if you must score within the top 10% on your law exam to be eligible for a job? So you want the top 10%. If the distribution for scores is normal and you made a 72 on the test, so that's your data value, and the mean for the test is 65 and the standard deviation is 4, what percent of those who took this test was below yours? So you want to score the top 10%, and then this part is below yours, which would be 90% is below yours. Okay. So what would we do here? Well, we would first need to find the z-score. So we would do 72 minus 65 over 4. So our z-score here would be 7 over 4, which equals 1.75. Okay. So remember here, we're going from here to 1.75. Okay. And when we do that, we get 45.99%. That means it was 0.4599. Okay. And remember, so this represents 45.99 and this represents 50%. Okay. So we want to know if you are in the top 10%. Well, you fall here, and if we look at what percentage this would be the 95.99% because we add these two percentages, okay? So do we score within the top 10%? Yes, we do, because we're over the 90% mark, if that makes sense. So do you score within the top 10%? Yes, okay? Yes, you do. And what percent of those who took the test was below yours? So what we would do is take 100 and subtract your 95.99. So that means you were in the top 4%. So 95% of the people scored below you. Okay. All right. Given the following, Ty Cobb hit .420 in 1911 and Ted Williams hit .406 in 1941. In 1910, the mean batting average was .266 and the standard deviation was .0371. In the 1940s, the mean batting average was .267 and the standard deviation was .0326. Assume this is a normal distribution. Use the z-scores to determine which batter was ranked higher. So we need to find the two z-scores and compare those. So in 1911, so we'll compare that to this one, and then we'll compare that to this one. So 0.420 minus 0.266 all divided by 0.0371. And then we're going to compare it to 0.406 minus 0.267 all over 0.0326. So we're comparing Ty to Ted here. And when we do that, we'll end up with 4.15 approximately. And over here, 4.26. Okay. So obviously here, Ted was ranked better because he had a higher Z-score, okay? Which means more percentage of people falling below him, okay? And that is everything, okay? So make sure you could try a few problems in this in the back of the book just for some extra practice. And then your test is going to be next week on 4 and 5. And please make sure you work on your project.